Good morning, everyone. Welcome to the first talk in this room. This is Plan Your Next Eclipse Viewing with Jupyter and Geopandas by Christy Heaton. She has requested that she'll be taking your questions outside after the talk in the hall, so please hold off your questions until then. Christy.
Thank you. Thank you for coming, fellow map nerds. So I'm going to be talking about how you can plan your next solar eclipse viewing with Jupyter and Geopandas. My name is Christy. I work for an environmental consulting firm in Seattle called Floyd Snyder as a data analyst, and I make maps there. I'm also the organizer of a group in Seattle called MapTime Seattle. We're on meetup.com. We focus on learning open source geospatial tools together, and we also have fun social events like Mappy Hour. So if you are interested in that and ever in Seattle, please find us on Meetup. So this entire presentation is running inside of a Jupyter Notebook. I love Jupyter Notebooks for spatial analysis because you can document all your code and you can see your plots and maps right there in the notebook. So here's a little proof. And these are live cells that I just ran. Okay, maps. Cool, that's why we're here. So did anyone use a map to find the convention center once they got to Cleveland? Or have you ever gotten a text from a friend asking, where are you? And your application prompts you to share your location? Does that happen? Yeah, we're surrounded by maps. I use a map to find my bus every morning to find out when it's coming, and I also make maps for my job. Maps are the best way to understand a network, anything spatial, even if how I would define a map is anything that helps you understand something spatial. Like it doesn't even have to be to scale like this DC Metro map. So even though maps are embedded in all our technology, they've been around a long time, and people have been using them to understand their area and to even do spatial analysis for a long time. This is a historic map of Cleveland. So when I tell people that I make maps for a living, they sometimes ask me this question: hasn't everything already been mapped? Well, the short answer is no, but to explain it, there are a lot of different kinds of maps. So this is an aerial photo taken by a satellite. I would say this is a map. It's just a photo, but it tells you like what's there. Really nice aerial imagery. And maps can also be really heavily stylized. These are not based on imagery, based on like data layers and styled. I really like this. These are open source maps from a company called Stamen. They make these really nice styles. We're going to use them later. And if you've ever used Google Maps, which you probably have, you might have noticed you can switch between like an aerial imagery and this kind of stylized map, whatever suits your need better. So in contrast to those two kinds of maps, I would call those base maps, at least for my purposes, because they just show you what's there, the image and the stylized map. This map, in contrast, I would call a thematic map because it has data on top of it. And the data we can see from the title is climate destabilization, and we've got all these different shades of orange, which we can, even if we can't read that text, we can assume the darker orange color is more climate destabilization, and this map also has little information nuggets on there, and this is closer to the kind of map that I make. And even if all the base maps have already made and all the thematic maps have already been made, there's maps of Middle Earth. I met someone who was trying to do a spatial analysis using the map of Middle Earth. If you're familiar with The Lord of the Rings, it's the story of this hobbit named Frodo who carries this ring from Hobbiton to Mordor. And this guy was looking at if he had taken the shortest path. And even if, even like there are other planets and galaxies, you can even make maps of the brain and body. So, of course, not all maps have been made. So I make maps with Geographic Information Systems, or GIS. And GIS is a system that allows you to work with spatial data, visualize it, analyze it, store it properly in order to understand it better. And GIS is used in organizations of all sizes, in every level of government, NASA. I use it for environmental consulting. Real estate uses it, so it's widely used. And then what really drew me to the subject of GIS was that it was a fun mix of data, science, analysis, and maps. I love all those things. So we use GIS to answer where questions or questions with some kind of spatial component. So like, where's the convention center and how do I get there? Also, like, where should we put the next something? We call these site selection problems. Where should we build our next store? So that, well, first of all, we need a spot that has the right zoning, that's available for sale, that is going to draw in our most customers. So we can use GIS to find the best spot for that. And the same thing with like a wind turbine or a solar panel. For example, you might not want to put a solar panel in Seattle because, well, I'm just kidding, we have some. Disaster relief or prevention, finding out where a storm is going to hit so you can evacuate the right people and also provide aid after a hurricane hits. What I do a lot in my job is find out which area in our cleanup area that we're trying to clean up with at the firm has the highest concentration of some chemical so that we can apply the best remedy there. And it's also used by advertisements to target you and based on your location, among other things. So before we get into our spatial problem, there's a few things to know about spatial data. One thing is the Earth is round, and all of our maps on the screen, on paper, are flat. So they have all been projected somehow, and I'm not going to get too into this because there's a lot of ways you can project something, but it's just good to know whenever you're mapping on a flat surface that you're dealing with some kind of distortion. And distortion can happen in various aspects of your map. Imagine like taking a grapefruit, peeling it, and then flattening out that peel. It's going to be all warped and torn. So we do our best using math to find projections that are that minimize distortion, and there's a lot of projections that you can choose from. Another thing to know is a coordinate system, and this is how you identify a location on the Earth with two numbers, just like in geometry class where you have an X and Y coordinate system, and you have these two numbers that help you identify a point. Just like projections, there's a lot of different types of coordinate systems. The one that we're going to use today just happens to be the geographic or unprojected coordinate system. And this one is what has an island. So this one, it covers the entire Earth, and it uses latitude and longitude. The equator is the line of latitude 0, and the prime meridian is the line of 0 longitude. And so it does have that 0, 0 origin, which we jokingly call null island, because if you ever bring any data that is incomplete or has missing coordinates, it's going to end up right there. And it's good to be aware. We joke about that so much data has formed up in that spot that there's an island there now. So when we're using spatial data with Python, we get this kind of projection coordinate system combo called an EPSG code. And so you can look up the code for the system that you want to use. So this talk is about planning your next Eclipse viewing, which is just a really fun way to talk about maps and doing spatial analysis. But this topic is really fun because I remember what really got me into it was the eclipse that happened on August 21st, 2017, which is my birthday. Went with some friends. I live in Seattle, so went with some friends to Oregon to see the totality. So if you're not familiar with what a solar eclipse is, it's what happens when the moon comes directly between the sun and a point on the Earth. And when this happens, you can look directly at the sun and see something that looks like this. Did anyone here see the totality? Yeah. So after I saw that eclipse, I was talking to my sister, and I was like bragging, like it was so cool. She had missed it. She had heard like that traffic was going to be bad, or that it would be really hard to find a spot to see it. So we were talking, and I was like, well, you can see there's more coming up. You can see them. And she wanted some help planning more in advance this time. So I identified this as a spatial problem. And after we talked, we came up with some criteria that were of interest to her in finding out where she could go to see the next solar eclipse. So she wants to know, first off, when and where can she go to see an upcoming solar eclipse? And then she's really interested in sharing the experience with a lot of people. So she wants to know which upcoming eclipse is going to pass over the most people. And then once we have that answer, where can she go to see that eclipse? And she wants to go to a large city, so she can fly there and get accommodations. And if you have totally different criteria than this, you could use the same process to answer it for yourself, just you'd have to find your own data. So to answer these questions, we're going to use some Python mapping libraries. We're going to use matplotlib, which is a really nice plotting library. Makes really publication quality maps and diagrams. They can be both static and interactive. So we'll import that. And then we're also going to use pandas and the Geopandas, which is mentioned in my talk title. So pandas is used primarily for data science. It provides these easy-to-use tabular data structures and data analysis tools. So it's pretty popular for data science. And then Geopandas is pandas that's been geographically enabled. So it still has those tabular structures by pandas, but it also has a spatial component provided by another library called Shapely. So we'll import both of those. And just so you know, I'm showing code. If you can't see all the code, it's all available on my GitHub, and it's all the instructions about how to get it running. So I'll tweet about that later, and my Twitter handle is really teeny tiny in the corner. So let's get started. First, we need to make a base map. So Geopandas comes when you download and install it. It comes with some spatial data that you can use right off the bat. So one of the things is worldwide countries. So I can load that in as a Geopandas geodata frame and assign it to a variable. And then since it's spatial data, we want to make sure we at least know the coordinate reference system. That's what CRS stands for, and it will return us that EPSG code that I mentioned earlier. This one is 4326, which is that the geographic worldwide coordinate system, latitude, longitude. So just like with a pandas data frame, it has this tabular component. So we can look at the columns that we have to work with. We have population, GDP, country name, and this geometry column, which holds the spatial information. So then if we plot that, using all the default customizations, we get this nice little visual of what we have. But usually when you're working with these kinds of maps, you want to customize it. So here I've made the plot a little bit bigger, colored things a little bit differently so that you can see everything a little better. So now we have a nice base map. For the rest of the data sets, I've downloaded data that I want to use outside of Geopandas. So some cities. Geopandas actually does come with city data, but it's only capitals, and I want as many cities as possible for my analysis, so I've downloaded them from another place and loaded them in. And then anytime you're plotting data on top of each other, it needs to be in the same coordinate reference system, so I'm just checking to make sure it is. And we can look at the first few rows of the tabular component. Here we have names and populations, and then that same geometry field. So if we plot the cities, now we have a map where each city is a dot in the location that it exists. And you can use Python to do quick checks of if everything's in the right coordinate system. Probably want to do that. Then we can plot both of them together after we verify that they're in the same coordinate system. So to do this, you add your base map to a variable. You can call it whatever you want. But then any data that you want to add on top of it, you give it this axis equals whatever you set the base map to. And then you can do this as many times as you want. You can put 100 data sets on. So now we can see where the cities fall in line with the land masses. And yes, there are cities out here, I guess, on little islands. So now we have a base map. My sister wants to know where she can see an upcoming solar eclipse. So I went to nasa.com and downloaded some data for upcoming eclipses and cleaned it up. They don't all plot really well if they're on the North Pole. So sorry, I removed those. So we have eclipse data, and just like with cities and countries, we'll check the coordinate reference system, see that it's in the same one. And then we'll look at the first few rows. So what we're going to use to identify our eclipses is the year that they're going to occur. We can always find out more specifically when they're going to happen later. And then we can plot the eclipses. And I have styled these eclipses like the way I see an eclipse, being like shadowy in the middle and kind of bright yellow on the outside. You could style them however you wanted. And then we can plot those on our country data to see where they fall. But she wants to know when and where she can see an upcoming solar eclipse. So another thing we can do is take that year column of the eclipses and color each year differently. So now we can kind of see, and we could choose to color these differently from like most recent to farthest away color shading. But in this case, I've just given them all a random color. But we have a legend so we can tell which is coming when. So there's a few coming South America pretty soon. One over Antarctica, North Pole, and this one coming over the United States. So this answers her first question. So now she knows when and where she can see an upcoming solar eclipse. Now, which eclipse is going to pass over the most people? And this is going to take a little bit more spatial analysis. So in order to answer this question, we need to pull in our city data, which does have populations associated with it that we can use. But first, I just want to plot everything on the map together. So just visually, we can now see that there are a lot of cities that overlap with a lot of eclipses. So we need to find out the total population of all the cities inside of each eclipse. So to do that, I'm using spatial intersection, just pulling out all the cities that are inside of the path of any eclipse and giving that its own variable. So now I have a subset of cities. And just take a look at the first few rows so I can see that it worked. And now these are the cities, but now they have this year column, which has the eclipse that they're going to overlap with. And then all I really need from this result is the population and the year. And I'm just going to put that into a data frame so I can do a summarize on it. But first, I'll just take a look at it. Now I just have the population and the city and the year. And now I can do that sum. So I'm taking that data frame, I'm summing all the years by the populations. And then we should just have a small table that just has the year and the total population of each eclipse. But now we've lost that spatial component. This is just a data frame. Still useful, but we can join it back to our eclipses spatial data. I'm making a new variable, and I've got just it's got the same eclipses as before, but now we've joined that population column back to it. And now if I look at the tabular component of our eclipses, we have this total population column. So from there, I can sort this and find out which, if I just sort descending on population, I can find out which eclipse is going to have the most people, and it's the one that's happening in 2024, looks like. So now I've made my same plot, but I've colored the eclipses by their estimated population. So the darker the color, the more people the eclipse is going to pass over. So it kind of looks like this one is the darkest. And then this is the same plot I made before where each eclipse is colored randomly by the year. So now we can just verify that this was the darkest one, this is the one happening in 2024, and it's the one that's going to pass over the most people. And that's the answer to her second question is, so it's that one. Now we're going to take a closer look at that one and find out which cities in that path are the largest. So we only need that eclipse now. I'm just going to pull that one out into its own variable based on the year. And then if I do my plot again with my new eclipse, it's just showing that one, so we can really focus on that one. And now I just want to change the zoom of my plot to like the minimum bounding box of that eclipse so that we're focused right on it. And when you change scale, you often want to take a look at your styles too, because sometimes it looks better with a different styling at different zoom levels, basically. So I'm going to change my style now to my cities are these little dots. So we want to find out which of these cities inside the path is the largest. So first we need to find out the cities that are inside of the path, and this is the same code we used kind of initially to find out all the cities that overlapped with an eclipse. Now we just want to know the cities that overlap with our 2024 eclipse. And if we plot that out, that looks good, that looks right. Got all these cities inside of there. One thing you can do to try to find the answer is size your city dots as a ratio of the population associated with them. So now our bigger dots are bigger cities, but still really hard to tell what's going on there. But something fun you can do. But we actually have the answer already. We can sort descending on our cities that overlap with that eclipse. Sort descending, and we'll find the top 5. One of them is Cleveland. Then we can take those cities and make our own little subset of them. So we just have the top 5. Plot those out with labels, and that's the answer. But the problem is my sister doesn't know Geopandas. She doesn't know Jupyter. So how am I going to, and she's also used to maps that you can zoom in and out that are interactive. So I'm going to have to deliver this to her in a format besides this. In GIS, we call interactive base maps Slippy maps because they slip around when you drag them. So to make a Slippy map, this is all still in a Jupyter Notebook, by the way. I'm going to import Folium, which binds the power of Python with Leaflet.js. I don't know what that means. Import it. And then, I just looked at the documentation on how to quickly make these maps. So I'm pulling in, these are Slippy. This is from OpenStreetMap. You can look on the documentation. There's a lot of different base maps that you can use. But to make this Folium map, you just have to give it a location to start. And you can always change it, move it around later. And then you also need to give it a zoom start, and this is the zoom level that it's going to start in. And zoom level is how zoomed in or out it is. But you can always zoom in and out whenever it's made. So that's nice. I just want to take a look at some other of my base map options. I really like this one, black and white, crisp. But the one I really like is this watercolor base map. And this is based on real data. It's just styled like a watercolor. I guess it never gets any labels, but it looks really pretty. And I like to use this map when I'm doing something fun because I can't use it at work. So to map our eclipse data on one of these, I need to find the centroid of my eclipse so that I can say that's where I want the map to start. Do that with some centroid, find the centroid x and y. And then I need to make it the map, but then add my data on top of it, but first it has to be converted into GeoJSON, whereas before it was Geopandas data frames. And then I can add once I do that, I can add my top 5 cities and my eclipse data onto the map. So if I plot it, now I have my top 5 cities and my eclipse. But I don't have anything, I don't know what cities these are. They're just little markers, so I have a little more work to do. I can, with a little more code, write a function that both creates my map and generates these little pop-ups that have the name of the city and the population associated with them and define how I want them to look. And so now it's in a function form. So to create my map from here, I call the function. And now it looks almost the same, except my little cities are now these dots that I can click on and see the population. So there's Cleveland, be here in 2024. This is still not quite ready for my sister. I need to save it as an HTML file that I can attach to an email and send it to her, and then she can open it up. So that opens for me. She's going to get something like this. She can open it up and be like, yay, I'm used to this kind of thing. So yeah. how you plan your next Eclipse viewing with Jupyter and Geopandas.